You guys know what happens when you are stuck in your classroom by yourself for long days? You start to go crazy. So, yes, I am wearing pajamas because it's pajama day for Utah School Spirit. In case you were wondering, I just don't wear this every day. So, the last video you watched was about chi-squared goodness of fit tests, which is where we see if a model fits a certain distribution, right? So it either is what they claim or it is not what they claim. The other chi-squared tests, which will be the second and only, because we're only going to learn two of them, is independence. So chi-squared independence is just looking at, hey, are these two variables, and they're actually qualitative. So are these two qualitative variables, are they independent of each other or are they dependent? So does one influence the other or not? So like the other chi-squared test, this one, the null and alternative hypotheses are super easy, and they're pretty much the same every time. So then the null hypothesis would be that the variables are independent. Okay, and you can actually say what the specific variables are, which I'll show you an example in a second. So, and then the alternative would be they're not independent or they are dependent. Okay, and I'll show you an example in a second. So the chi-squared test statistic is the same way as with the goodness of fit one. It's the observed minus expected squared divided by expected, and you add up all of the categories. However, this independence test is looking at two different variables, right? So variable one, then we're looking at variable two. So in a second, we're going to look at what level you teach at, does it affect their satisfaction level of their job. Okay, so with this one, we're going to have more than one column and more than one row, right? So the degrees of freedom will be the number of rows minus 1 times the number of columns minus 1. So if I had 3 columns here for variable 1, then I had 4 columns, so it's like this, right? I had 4 rows for variable 2, then I'd go 3 minus 1 times 4 minus 1, and that would be the degrees of freedom. Okay, I'll show you an example in just a second. And then if you want to find the expected counts, you can do it using this formula, which will be on your formula sheet for the final. So you don't have to memorize this, just know how to use it. The expected counts is the total of the row times the total of the column divided by the total sample size. So like if I wanted, let me change my color. So if I wanted to know this expected counts for this cell, then I could go this total, because this would be the total, right? This is the coolest pen, you guys. Anyhow, so I could go this total, whatever that is, times this total divided by this grand total. And that's how I would find the expected counts for just that cell. The other way you can find the expected counts is on the calculator, which I'm going to show you in just a second. And that shortcut to find the expected counts will also be on your formula sheet. So I advise that as I'm walking through this example, you choose which one you want to do, whether you want to know how to use the formula, which is pretty easy, or you want to just remember how to find it in the calculator, okay? All right, so we are going to look at this poll of 661 teachers. And what they did is they were asked their teaching level and then how satisfied, or whether they're satisfied with their job or not satisfied with their job. I'm sure if this was done today, it'd be different. But anyway, I can't remember exactly when this was done, but it was a few years ago. So this is a chi-squared independence test because we want to know if job satisfaction and teaching level are independent. So you know right there, if it mentions independent or dependent, it has to be a chi-squared independence test. Plus, we don't just have one row of things. So think of like with the M&Ms example, we just had one column or one row, and that's it. So that is the goodness of fit. But when we have more than one column and or row, then it should be the independence, since that's the only one we're learning right now in 1040. So then my null hypothesis here will be, sorry, it's hard to write and talk at the same time. Job satisfaction, we'll write neatly, I should say. And teaching level. So whatever the two variables are, which these are the two variables that we're looking at, are, what's the null always going to be? The null is always going to be there, independent of each other, okay? Teaching level are independent. Okay, and then the alternative is that, and I'm going to have you guys actually write it out, but for the sake of this video and my awful handwriting right now, I'm just going to say they are dependent. And you guys will know, or you can do the ditto marks, remember? Okay, so null and alternative hypotheses, easy peasy. Those two are independent as the null, alternative as they are dependent, whatever the two things are. Okay, next thing, you guys are gonna love the chi-square test because they're pretty much all done in the calculator. It's awesome. So the first thing we're gonna do is we're actually gonna create a matrix. And you guys haven't learned what a matrix is yet, but I'm going to show you where it is in the calculator.
Teachers, the lunchroom has brought corn dogs into the office. If anybody wants a corn dog,
if you guys want a corn dog, just kidding. It'll be too late.
Fridge and everything. So occasionally they'll just be bringing some food down. But we have a few corn dogs here. If anybody's hungry, come grab one.
I bet you Barkley goes. What do you guys bet? Just kidding. Okay, so the button next to the 9. See this? That has all these options like fraction, square root, a different radical, log, has all this stuff, right? You're going to select this one in the middle, this 3 by 3 square. You could say you're going to select that. And then it will say, hey, you want to create a matrix? And you're like, yes, I do. So how many rows are there? Well, there's 2 different rows. There's just high school and elementary, right? So I'm going to change that to 2. Oh, go back here. And then there are 2 columns as well because they're either satisfied or not satisfied. So, and I'm not including the totals. So that's important to know. So I'm just putting what is in the actual table itself without the totals. Okay, so go to OK, and then it will bring up a matrix and you fill in what the numbers are, exactly where it should be. So 224 is right here, so I got to put 224 there, and 171, and then 126, and 140. You just enter it in exactly how it shows. And then I'm going to arrow out of the matrix, so the cursor is just flashing to the right. Now we need to store this. So we need to save this matrix as something to use it on a test. So the store button on the calculator It's STO right above the variable. See that? So I'm going to push control variable and it will do the arrow, and then you just have to name it something. So it needs to have, excuse me, it needs to have at least one arrow. Oh my gosh, one letter. So I'm just going to put T for teaching, and then I'm going to just push enter. Okay. And then it will just show it again. So, but now we have stored it, because now we are going to do, and this will be, I actually added it to your formula sheet on your final. You're welcome. I added this shortcut. Let me go back to my pen here. So once you have it stored, then you push menu. Pretty sure it's 678, which is easy for Blanding residents to remember, right? So menu 678. Okay, this is the chi-squared 2A test, is the same thing as independence test. And now hopefully when you push the right arrow, it selects, or you see your stored matrix. When you go to push menu 658 or 678, nothing's there, then you know that should remind you, oh crap, I forgot to store it. So need to do that. So anyway, then just hit OK, and then that's it. There's your chi-squared, which is your test statistic. So we always put that down. Chi-squared is the 5.56. So therefore the p-value is 0.018 or 1.8%. Okay. Degrees of freedom, it actually says it there. So it won't say how they got it, but the degrees of freedom, remember, was columns, columns -1 times rows -1, which is why it's 1. Okay, so then we can conclude the p-value is less than our level of significance, which is the 5% that we have been referring to. So since it's less than 5%, we are going to reject the null. And that means we have evidence of what? The null was saying that teaching level and job satisfaction are independent, which means they don't influence each other. And we have evidence here that teaching level and job satisfaction are dependent, which means teaching high schoolers affects whether you're satisfied with your job, or first graders, I guess, but no comment there. Okay. Now, the one thing I was going to show you, well, if you had a question, which you will have questions like this, so when you have a question, say there was a question, what's the expected counts? So how many can we expect from our sample counts of high school teachers, or secondary level, right? High school, I should say secondary, my bad, because that's what is used in the table, right? No, high school, I was right, sorry. High school that are satisfied with their job. So this is asking, hey, based off of your numbers you have here, how many can we expect to be high school teachers that are satisfied? So what's the expected count right there? So you can, this is where you can use this formula. So you can go the total of the row times the column total divided by total sample size. So that would be 395 times 350 divided by 661. That's one way that you could find the expected counts. The other way, in the calculator, now that we actually have done this test, all you need to push is VAR for variable, and then stat.expected matrix. Okay, so variable, then stat.expected matrix, hit enter, and there's your expected counts for each cell. So if I want to know, well, high school that are satisfied, was that the top left cell? Yes, that was. So then top left number is the 209. So I expect 209 out of my total sample of 661 to be high school teachers that are satisfied with their job. Okay? So hopefully this helps you have an idea of how to do the chi-squared independence test. Remember, tomorrow at, when is it? 10:30, I think, is a Google Meet, and I'll answer all your questions about chi-squared test. Thank you. Have a good day.